Bismillahirrahmanirrahim. Okay, so we have discussed on the first part of the electrolytic cell, okay, in which the first part of the electrolytic cell is on the qualitative analysis, in which we have discussed how to predict the products that should be produced at both electrode, anode and cathode. Okay, and we also have looked at to the factors that might affect the production of the product that will undergo oxidation or reduction at anode and cathode. Okay, so we have discussed there are three factors that we have to consider. Number one, we have to consider the type of electrolyte that we use. Either it is pure or it is aqueous, or we have only H2O, okay, in our as our electrolyte. That is for the first factor. Second factor, we also need to consider the concentration of the electrolyte. Okay, for example, when we have a brine solution, when we have a concentrated sodium chloride and we have a dilute sodium chloride, it will lead to different products. Okay, and then after the concentration, the third factors that we need to consider when we want to predict the product is the type of the electrode that we use. Okay, sometimes we have a active electrode, okay, and sometimes we are using the inert electrode. Okay, so when we have an active electrode, means that we need to also consider the active electrode to be involved in our reaction so that it might lead to different product as well. Okay, so these are three things that we have to consider when we want to determine the products at anode and cathode. Okay, so that information is then we need to bring it to the second part of this electrolytic cell, which is the quantitative parts. Okay, so it is involved calculation because we are using the term of the quantitative. So please make sure that you have your calculator with you now. Okay, calculator in your hand. Okay, and in this quantitative part, we will apply the Faradays Law. Okay, when we want to solve our question, okay, the calculation, we will always apply the Faradays Law. Okay, so what is the Faradays Law? Faraday said that, okay, the amount of the substance that is produced at each electrode is directly proportional to the quantity of the charge that is flowing through the circuit. Okay, so the amount of the product that is produced at the electrode, we know that this is the example of the electrolytic cell. Okay, we have a cathode here, the negative electrode that is connected to the negative terminal. Okay, so this is the negative terminal of the battery, so that it will be connected to the negative electrode, which is our cathode. Okay, and this is the positive terminal, so it is connected to the positive electrode, which is anode. Okay, so this is a cathode. Okay, what happened is in this electrolytic cell, okay, the Ag plus, okay, as the electrolyte here will goes to the cathode and undergo reduction. So when the Ag plus undergo reduction, it will then coated this spoon. Okay, it will coat this spoon. Then this is what we call as the electroplating process. Okay, so when it coat this spoon, okay, this is actually the reduction that is happened at the cathode. While at the anode, what happened is the oxidation. So what is oxidized? Since that we are using active electrode here, we are using the Ag itself, the silver itself, so that the silver solid will undergo oxidation, then turns to Ag plus. Okay, so this is the products that is produced at the anode, Ag plus ion that is produced, and Ag solid that is produced at cathode. So the Faraday's law state that the amount of the substance that is produced, so in this case the amount of the Ag solid that is produced at cathode and the amount of the Ag plus that is produced at the anode is directly proportional to the charge that is flowing through the circuit. Okay, the charge is, or the electron is moving from the anode to cathode. It is always, this is the cycle from anode, it goes to the cathode. Okay, that is for the movement. So the more silver that is deposited here, or the more product that is produced, okay, at the anode and also cathode, it means that more charge that is flowing through in our circuit. Okay, that is the Faraday's law. Okay, or the more charge that is flowing through, it means that it will produce more product at the anode and cathode. Okay, because we know that the product will be produced both. Okay, so we need to, when we look at to the electrolytic cell, you should be able now to identify what should be produced at the anode and cathode after we have learned the first part, which is the qualitative part. Okay, that is on the Faraday's law. Okay, mole of the substance that is produced at the electrode is directly proportional to the electrical charge, and the unit for the electrical charge is coulomb. That is the Faraday's law. Okay, now let's look at how can we answer, what is the steps that we have to follow when we want to answer the question in this quantitative based on the Faraday's law. Okay, so firstly we have to know what's the product at each electrode. Okay, sometimes the question already told us, okay, the hydrogen gas produced, for example, it said that the copper solid is produced at the cathode. Okay, sometimes the question told us, but sometimes you need to predict it on your own. Okay, and then you have to come up with the equation of a reaction. Contoh, example, if we have a Ag just now, right? Okay, there is no equation that is given, but we should know that the Ag solid that is produced here. Okay, so you should be able to come up with the equation of a reaction. What is happened at the cathode will be Ag plus aqueous plus with the electron, since that it is undergo reduction at cathode, then it turns to Ag solid. Okay, as for the anode, what is happened is the Ag solid from the electrode, okay, turns to Ag plus aqueous with 1 mole of the electron. Okay, so this is what happened at the anode, and this is what happened at the cathode. So you should know that from this equation. Why we have to have the equation and we have to make sure that it is balanced? Then we will know for every 1 mole of the Ag that is produced, 1 mole of electron that is transferred. Okay, that is added to the our reactant Ag plus. As for this, for every 1 mole of the Ag plus that is produced, 1 mole of the Ag solid that undergo oxidation, then 1 mole of the electron will release or involve. Okay, that is what we got from the equation. Sometimes it is not 1 mole. For this case, it's 1 mole, 1 mole. But if you have a copper 2 plus, for example, it is for every 1 mole of the copper 2 plus, okay, aqueous to be undergo reduction, okay, it needs 2 mole of the electron so that it will form 1 mole of the Cu solid. Okay, so the ratio between the electron and also the product is important because we will use it. Okay, so first identify the products, and then next is to determine the amount of the electrical charge, or Q. Okay, Q is electrical charge that pass through the circuit. This is what Faraday said. Okay, the amount of the products, okay, that is formed is depends or directly proportional to the amount of the electrical charge that passing. Okay, so we need to be able to determine the electrical charge by implementing this equation. Q is equal to IT. I is the current applied and T is the time for the reaction. Okay, so of course that, okay, the greater the current that we use, okay, in a unit of ampere, the more current that we use, it will leads to more or greater charge that is flowing. The longer the time that we give for the reaction to occur, then the more charge that is flowing. So our Q will be greater because it is directly proportional to the time and also to the current applied. Okay, so that is on the charge. Then next is we have to know that for every 1 mole of the electron that is transferred, Okay, it is 96,500 column of charge that is flowing. This is the relationship between the charge that we calculate here, Q, with the mole of the electron. Okay, so this is actually the Faraday's constant. 1 mole of electron means that 9.65 times 10 power of 4 column of charge that is moving. Okay, so we will apply this. So if we have a 1 mole of the, in this case, 1 mole of the Ag solid that is produced, okay, we know that 1 mole of electron that is transferred. So if we have 1 mole of this Ag solid that is produced, means that the charge that is flowing is 96,500 coulomb. Okay, if we have 1 mole of the Ag that is produced. If less than 1, then we need to calculate the ratio. Okay, and then we have to relate, after we got the number of mole of electron, we can relate it with the number of mole of the substance that is produced. Okay, because how to get that? This is what we have done just now. For every 1 mole of copper that is produced, okay, means that 2 mole of electron that is transferred. So from the charge just now, the column, we calculate how many mole of electron. Then from the number of mole of electron, we can calculate the number of mole of the product. Okay, so the products is not necessarily to be solid substance only. Okay, the products can be a gases. Okay, so if it is a solid, okay, the products can be solid. If it is a solid product, for example, copper, silver, the metals, they are all solid substance. Okay, we can calculate the number of mole. Okay, or we can calculate the mass. Okay, from mole we can calculate the mass, okay, by multiplying with the molar mass. Okay, that is if you have a solid sample. If let's say we have a gas product, okay, for example, the oxidation of the H2O. Okay, when H2O is oxidized, it will produce oxygen, right? Okay, so the oxygen will produced at the anode. So we can calculate the number of mole of the gas that is produced, and then we also can calculate, instead of calculate mass for gas, we can calculate the volume that will occupied by that gas product. Okay, then how to convert from mole to volume? Okay, so to convert from mole to volume, then we need to apply back, okay, the PV equal to nRT that we have learned before. Okay, PV equal to nRT, since that we want to know what is the volume, so make it as a subject so that the volume will be then equal to nRT over P. Okay, so these are the summary of the steps. Okay, the product only two lah. Okay, solid or gases. Okay, so this is the diagram for the process. Okay, they are reversible. Okay, so if let's say we have a mass, okay, from the mass of the substance that is produced, we can calculate the mass of it. Okay, for example, we want to produce A, solid. Okay, we know the mass so that we can calculate the mole of the A that is produced. From the number of mole of the A that is produced through the balance equation, okay, we can calculate the number of mole of the electron. Okay, if let's say for 1A, it needs 2 mole of electron, so that we can get the number of mole of electron. Okay, and then by applying Faraday's constant, for every 1 mole is 96,500 charge or coulomb, okay, is transferred, so that we can calculate the Q or our charge. Okay, charge is Q. And then after we got the charge, then we can calculate the time, or we can calculate the current by using the equation of the Q equal to IT. Okay, depends on what the question want. Okay, or it will be the other way around. From the current and also the time that is taken, we can calculate the charge. And then from the charge, we calculate the number of mole of electron. And then from the number of mole of electron, we are referring to the balance equation. We got the number of mole of the product. Okay, and then we can calculate the mass of the product finally.